Hi, welcome back to my class in Analytic Geometry. For today, we will take up the graph of linear equation in 1 and 2 variables. And we will sketch the graph of a straight line whose equation is given by a linear equation in 1 or 2 variables. The general form or standard form of a linear equation in 2 variables x and y is given by the following equation: ax plus by plus c equals 0. This equation is the general form or standard form of linear equation in 2 variables. Why linear? The variables x and y are said to be linear because the exponent of x, the exponent of the variable x is 1, and the exponent of the variable y is 1. Hence, this equation in the variables x and y is said to be linear in 2 variables x and y, because the exponent of each of the 2 variables x and y is 1. Hence, this is an equation linear in 2 variables. And this is called the general form or standard form of a linear equation in 2 variables. In this equation, the coefficient of x is a, coefficient of y is b, and the last term at the left-hand side is a constant term. Now, the coefficients of x and y cannot be both 0. That is, a cannot be equal to 0, and at the same time, b cannot be equal to 0. Because if both coefficients of x and y, a and b, are equal to 0, the first and the last term will go. Because if a is 0, 0 multiplied by x is 0. If b is 0, 0 multiplied by y is 0. And this equation would simplify to c equals 0. And in general, this c equals 0 is not true if the constant term of this equation is not 0. Although c can be 0, and this will be true, but generally the constant term of this linear equation in 2 variables is not 0. If c is not 0, this will not be true. Hence, the coefficients of x and y cannot be both 0. But if either one of the coefficients of x or y is 0, then we would get a linear equation in only 1 variable. We start with a equals 0. If the coefficient of xa equals 0, then this general form for the equation of a line linear in 2 variables x and y would simplify to by plus c equals 0. by plus c equals 0. And we take the coefficient of y, b, as a non-zero number. Again, if the coefficient of x is 0, but the coefficient of y, b, is not 0, this linear equation in 2 variables would simplify to by plus c equals 0. because a is 0, a 0 multiplied by x is 0. Hence, this simplifies to by plus c equals 0. And this is what we call a linear equation in only one variable. And the variable is y. We say that this linear equation is linear in y. And the graph of this linear equation in y is a straight line. And from this equation, we can readily solve for y by transposing c to the right side and then dividing both sides by b. And we can divide both sides by b because the coefficient of y is not 0. We do that. We transpose positive c to the right, it becomes negative c. And we divide both sides by b to solve for y. And we can do this. We can divide both sides by b because the coefficient of y, b, is not equal to 0. And from the left side, b will cancel out. And we get y equals negative c over b. This is the solution of this linear equation in one variable y. Now we sketch the graph. We sketch the graph of a linear equation in one variable y. And of course, we sketch the graph of that equation in the Cartesian plane. With two axes, the horizontal axis is denoted by x. The vertical axis is denoted by y. The intersection of the two axes is denoted by point 0, known as the origin, and its coordinates are 0, 0. To sketch the graph of the linear equation in one variable y, you solve for the value of y, as what we did here. We transpose the constant to the right, and after the transposition, we divide both sides by the coefficient of y. If the coefficient of y is not equal to 1. And then after obtaining the value of y, or the solution of this linear equation in one variable y, we locate this value of y in the vertical axis. If the constant term here is negative, the value of y will be positive. If the constant c here is positive, the value of y, or the solution of this equation, the value of y will be negative. Suppose this constant term is positive, then the value of y, or the solution of this linear equation in y, will be negative. And suppose this is the point negative c over b. This is the value of y, negative c over b. To plot this point in the vertical axis, you count c over b units from the origin downward until you reach this point, negative c over b. Now, the graph of linear equation in one variable y is a horizontal line. And the horizontal line will pass through this point, or the value of y, which is the solution of this linear equation in one variable. The horizontal line, the graph of linear equation in one variable y, is a horizontal line passing through this point on the vertical axis. The horizontal line is perpendicular to the y-axis, and the horizontal line is parallel with the x-axis. So we sketch that line the horizontal line passing through this point on the vertical axis, perpendicular with the y-axis, and parallel with the x-axis. This horizontal line is the graph of this equation, linear in one variable, dy plus c equals 0. Again, the graph of linear equation in one variable y is a horizontal line passing through the value of y, which is the solution of the linear equation in y, and the horizontal line is perpendicular with the vertical axis or the y-axis, and the horizontal line is parallel with the x-axis. The graph of a linear equation in one variable y is a straight line. It is a horizontal line passing through a point on the vertical axis, and the horizontal line is perpendicular with the y-axis and parallel with the x-axis. Again, we consider the general form of linear equation in two variables, or we consider the equation of a straight line. Linear equation in two variables, x and y. We now suppose that the coefficient of y, b, is 0, b equals 0, and the coefficient of x, a, is not equal to 0. For this case, this equation, the general form of linear equation in two variables, simplifies to ax plus c equals 0. Because b, the coefficient of y, is 0, 0 multiplied by y is 0. Hence, the second term will go, and only two terms are left at the left-hand side of this equation. Ax plus c equals 0. This is now what we call a linear equation in one variable x. Or we simply say that this equation is linear in x. And to sketch the graph of this linear equation in one variable x, we solve first for the value of x. That is, find the solution of this linear equation in one variable, the way you did in your course in algebra. We transpose first the constant term to the right-hand side of the equation. And if the coefficient of x, a, is not equal to 1, you divide both sides by a. And you can divide both sides by a because we suppose that the coefficient of x, a, is not equal to 0. Again, we first transpose the constant term to the right-hand side of the equation, and we get ax equals negative c. The coefficient of x in the solution must be 1. If a is 1, then the value of x equals negative c. But if a is not equal to 1, you have to divide both sides by a. And we can divide by a both sides of the equation because we suppose that a is not equal to 0. And a will cancel out from the left side of the equation. And we get the value of x equals negative c over a. If the constant term here is negative, then the value of x will be positive. Or the solution of this linear equation in x is a positive number. If the constant term here is positive, then the solution of this linear equation in x, or the value of x, will be negative. Now, we sketch the graph of a linear equation in one variable x. Again, we draw the graph in the Cartesian plane that has two axes. The vertical axis is the y-axis. The horizontal axis is the x-axis. At the intersection of the two axes is the point 0, known as the origin, with coordinates 0, 0. And now we assume that the constant term here of this in this linear equation in one variable x is negative. We assume that this constant term is negative. Hence, the value of x here will be positive. And if x is positive, that point will be on the positive x-axis to the right of the vertical axis. We locate this point, x equals negative c over a, where c is negative, as we assume. Hence, the value of x is positive. And to locate this point on the positive x-axis, you count c over a units from the origin to the right. And suppose this is the point c, negative c over a. This negative c over a is positive because we assume that the constant term here is negative. C is negative multiplied by negative, it's positive. Now, the graph of this linear equation in x, in one variable x, is a vertical line. And the vertical line will pass through this point on the x-axis, or the value of x equals negative c over a. And the vertical line is perpendicular with the x-axis. And the vertical line is parallel with the y-axis. We construct that line, vertical line. This vertical line is perpendicular with the x-axis. It is parallel with the y-axis. And the vertical line passes through this point on the x-axis, which is the solution of this linear equation in one variable. And this is the graph of the linear equation in one variable x. Ax plus c equals 0. Again, the graph of linear equation in one variable x is a vertical line passing through a point on the x-axis, and that point is the solution of this linear equation in one variable x. If you would solve this linear equation in one variable x for x, that value of x is that point on the horizontal axis. And the vertical line is perpendicular with the x-axis, and the vertical line is parallel with the y-axis. Thus, if you have a linear equation in variable y, the graph of this linear equation in only one variable y is a horizontal line. And this horizontal line will pass through a point on the vertical axis or the y-axis, and it is perpendicular with the y-axis and parallel with the x-axis. While the graph of a linear equation in only one variable x is a vertical line that will pass through a point on the x-axis, which represents the solution of the linear equation in one variable x, and the vertical line is perpendicular with the x-axis, and the vertical line is parallel with the y-axis. Simply, a linear equation in y, the graph is a horizontal line. For a linear equation in variable x, the graph is a vertical line. We now consider the following examples. Sketch the graph of the following. In number 1, we are given a linear equation in one variable x. And the equation is 5x plus 10 equals 0. In number 2, we are also given another equation linear in only one variable x. The equation is 3 minus 5 times quantity x plus 2 equals 5 minus 7x. Because the two equations given are linear equations in only one variable x, we expect that the graph of these two equations will be vertical lines passing through a point in the x-axis perpendicular to the x-axis, and the vertical line is parallel with the y-axis. And to find that point of intersection of the x-axis and the vertical line, we have to solve for x from each of the given equation. We start with number 1. We have 5x plus 10 equals 0. We solve for x from this linear equation in one variable x. All the constant terms must be at one side of the equation, usually the right hand side. Thus, we transpose positive 10 to the right, and we take the opposite sign of 10, we get negative 10. The coefficient of x in the solution must be 1. But here the coefficient of x is 5. Hence, we have to divide both sides of this equation by 5 to make the coefficient of x 1 at the left hand side. We divide both sides by 5. And 5 will cancel out from the left side of the equation. And we get x equals negative, and 10 divided by 5 is 2. X equals 2 is the solution of this linear equation in variable x. 5x plus 10 equals 0. Its solution is x equals 2. Which means that if you substitute negative 2 for x in this equation, the sum will be 0. Now we sketch the graph of this linear equation in one variable x. The graph is drawn in the Cartesian plane with horizontal axis denoted by x, the vertical axis denoted by y, the intersection by the point 0 called the origin. To sketch the graph, you start with the solution. Locate this point, negative 2, in the x-axis. And to locate this point in the x-axis, you count 2 units from the origin. And negative means that the point on the x-axis is to the left of the y-axis or vertical axis. Thus, you count 2 units from the origin to the left. I will use 1 unit intervals, 1, 2. Negative 1, negative 2. This is the point x equals negative 2. And the graph of this linear equation 5x plus 10 equals 0 is a vertical line. Construct a vertical line passing through this point perpendicular with the x-axis and parallel with the y-axis. Construct a vertical line passing through this point x equals -2, perpendicular with the x-axis and parallel with the y-axis. And this is the graph of the linear equation 5x plus 10 equals 0. The graph is a vertical line passing through a point in the x-axis, which represents the solution of this linear equation 5x plus 10 equals 0 if you would solve it. And the graph is a vertical line perpendicular with the x-axis and parallel with the y-axis. Now we consider the second linear equation in only one variable x. We have 3 minus 5 times quantity x plus 2 equals 5 minus 7x. Again, the first step to sketch the graph of this linear equation in variable x is to solve the equation for the value of x. And to solve for x from this equation, we have to first remove the grouping symbols. Always start by removing the grouping symbols. And to remove the grouping symbols here, we apply the distributive property of multiplication over addition. Distribute -5 from the left. That is, multiply each term of this binomial by -5. The first term is 3. -5 multiplied by x is -5x. -5 multiplied by +2, negative times positive is negative. 5 times 2 is 10. We get -10. Equals 5 minus 7x. Equals 5 minus 7x. And the next step is to collect all the constant terms to one side, in one side of the equation, and all the terms with x at the other side of the equation. I will collect all the constant terms the right-hand side of the equation. That means we have to transpose +3 and -10 to the right. And we transpose -7x to the left. -10 we transpose to the right. And 3 we transpose to the right. And -7 we move to the left. Again, when transposing or moving a term from one to another side, to the other side of the equation, always take the opposite sign of the term. After the transposition, we have -5 at the left side of the equation. -5x. And -7, we transpose to the left, we get +7x. At the right-hand side, we have 5. And +3 transposed to the right side, we get -3. -10 transposed to the right, we get +10. Now, combine like terms at the left side and perform the operations at the right-hand side of the equation. We have -5x plus 7x, or 7x minus 5x is 2x. Equals 5 minus 3 is 2 plus 10 is 12. And finally, to solve for x, we divide both sides of the equation by 2. Divide the left and the right side by 2. And 2 will cancel out from the left side. That leaves us with x equals 12 divided by 2 is 6. x equals 6 is the solution of the linear equation in x given in number 2. And to verify whether this is correct, simply replace x in this equation with 6. And after performing the operations and simplifying, if this is a solution, the value at the left side should be equal to the value at the right side of the equation. Since we now know the solution of the given linear equation in x, we can now sketch the graph of this linear equation in variable x in the Cartesian plane, where we have x in the horizontal axis, y in the vertical axis, and 0 at the intersection. Always label the axis with x and y, and label the intersection of the two axes with 0 or origin. To sketch the graph, you locate x equals 6 in the horizontal axis. And to locate this point, you count 6 units. Since it is positive, you count 6 units from the origin to the right, or to the positive x-axis. And we do that. I will use a 2-unit intervals for the horizontal axis. 2, 4, 6. Again, the graph of this linear equation in x is a vertical line, and it will pass through this point 6, or which represents the solution of this linear equation in x. And the line is vertical. Construct a vertical line passing through this point in the x-axis. The vertical line is perpendicular with the x-axis and parallel with the y-axis. This is the graph of the linear equation given in number 2. 3 minus 5 times quantity x plus 2 equals 5 minus 7x. We take 2 more examples. This time, the given linear equations are linear equations in one variable y. Number 1, we are given 5y plus 18 equals 0. This is a linear equation in one variable y. In number 2, we are given y minus 2 over 3 equals 5 minus 2y all over 2. This is also an example of linear equation in one variable y, and the variable is y. As we said earlier, the graph of linear equation in one variable y is a horizontal line parallel with the x-axis, perpendicular with the y-axis, and passing through a point on the y-axis, which represents the solution of the linear equation in variable y. Thus, to sketch the graph of this linear equation in y, we first solve for y from this equation by transposing the constant term to the right side of the equation. And when we transpose that, we take the opposite side of 18, and it becomes negative 18. And we have 5y at the left side of the equation. And we divide both sides of the equation by 5 to make the coefficient of y 1 at the left side. And 5 will cancel out from the left side, and we get y equals negative 18 over 5. Or this is equal to 3.60. negative 3.60. You may give your solution as a fraction. Specifically, this is an improper fraction. Or you may give your solution to 2 decimal places. When you divide 18 by 5, the quotient is 3.6. But we want the answer to 2 decimal places, so we added 0. So the solution of this linear equation, 5y plus 18 equals negative 18 over 5 or negative 3.60. And you can check that by substituting negative 3.60 into this equation. And when you simplify, the sum should be 0. But the use of this solution is to sketch the graph of this linear equation in y. And we sketch the graph again in the Cartesian plane with 2 axes. The horizontal axis is represented by x. The vertical axis is denoted by y. And the point of intersection is denoted by 0 or the origin. And locate this value of y in the y-axis. Locate this point in the y-axis. Since the value of y is negative, this point is a point on the y-axis below the x-axis. You count approximate 3.6 units from the origin downward. I will take this as negative 3.60. Or you may write negative 18 over 5. And the graph of this linear equation in y is a horizontal line passing through this point. Thus, you construct a horizontal line passing through this point, negative 3.60 or negative 18 over 5. The solution of this linear equation in y. And this horizontal line is perpendicular with the y-axis and parallel with the x-axis. And you can label the equation of this line with 5y plus 18 equals 0. This horizontal line is the graph of the linear equation 5y plus 18 equals 0. And when we sketch the graph, we solve first this linear equation for y. And we get negative 3.60 or negative 18 over 5, which is a point on the vertical or y-axis, but below the x-axis because the value of y is negative. And we construct a horizontal line through this point on the y-axis. The horizontal line is perpendicular with the y-axis and parallel with the x-axis. Now we sketch the graph of this equation in number 2. It's also a linear equation in y. And the first step is to solve for y from this linear equation in one variable y. The first step is to multiply both sides by the greatest common denominator, or the lowest common denominator, the lowest number that can be divided by 3 and 2, and that number is 6. Again, multiply both sides of the equation by the lowest common denominator, which is the smallest or the lowest number that can be divided by 3 and 2. And that number is 6. But the way others do it, they simply do cross multiplication. That is, the numerator at the left side is multiplied by 2, the denominator at the right hand side, and the numerator, the right hand side is multiplied by 3, the denominator at the left hand side. That's cross multiplication. But you can only do this cross multiplication if both the left hand side and the right hand side have only one term. But if, for example, the right hand side of the given equation consists of two terms, 5 minus 2y over 2 plus another term, then you cannot do cross multiplication. You have to multiply both sides of the equation by LCD, or the lowest common denominator. But in this example, we can do cross multiplication, so we do that. We multiply 2 by y minus 2 equals 3, we multiply by 5 minus 2y. Again, so we have eliminated the denominators, but we still have grouping symbols in the equation. Thus, we remove the grouping symbols by applying distributive property of multiplication over addition or subtraction. That is, we distribute 2 to each term of this binomial, and we distribute 3. That is, we multiply each term of this binomial by 3. We do that. 2 multiplied by y is 2y. 2 multiplied by negative 2 is negative 4. Equals 3 multiplied by 5 is 15. 3 by positive 3 by negative 2 is negative 6. Y. So we have removed the grouping symbols. Now we collect all the constant terms to the right hand side of the equation, and all the terms with y to the left side of the equation. At the left side we have 2y. This negative 6y we transpose to the left, and we get positive 6y. Equals, we have 15 at the right hand side of the equation. Negative 4 we transpose to the right, and we get positive 4. We combine like terms at the left side of the equation. 2y plus 6y, we add the numerical coefficients. 2 plus 6 is 8. And we copy the common literal coefficient y. At the right hand side, we have the sum of 15 plus 14, which gives us 19. And finally, we divide both sides of this equation by 8 to get the value of y. We divide the left side by 8 and the right side by 8. 8 will cancel out from the left, and we get y equals 19 over 8. This 19 over 8 is an improper fraction, but you can always give your solution as a decimal number to 2 decimal places by dividing 19 by 8, and that will give you 2.375. 375 to 2 decimal places, that's 2.38. The value of y to 2 decimal places is 2.38. Now we will sketch the graph of this linear equation. Y minus 2 over 3 equals 5 minus 2y over 2. We now sketch the graph of the second given linear equation in y. Y minus 2 over 3 equals 5 minus 2y over 2. When we solve this linear equation for the value of y, the solution we get is y equals 19 over 8, which is approximately equal to 2.38 to 2 decimal places. Thus, the next step is to locate this value 2.38 in the vertical axis or y-axis. Since the value of y is positive, 19 over 8, this point is a point on the y-axis above the x-axis. The graph is constructed in the Cartesian plane with the horizontal axis denoted by x, the vertical axis is denoted by y, and at the intersection is the origin. We approximate 2.38 units from the origin and going upward. Suppose this is the point or the number 2.38 in fraction, it's 19 over 8. You can denote this point by 2.38 as long as the point has a label. And we now construct the horizontal line. The graph of linear equation in y is a horizontal line that will pass through this point. Y equals 19 over 8. And this point is 19 over 8, the solution of this linear equation in y. The horizontal line is perpendicular with the y-axis and parallel with the x-axis. And this horizontal line has equation given by this equation, y minus 2 over 3 equals 5 minus 2y over 2. Or the graph of this linear equation in y is this straight line. In particular, it is a horizontal line passing through the solution of this linear equation in y, perpendicular with the y-axis and parallel with the x-axis. Again, the graph of linear equation in x is a vertical line, while the graph of a linear equation in y, such as this equation, is a horizontal line. Now, for your practice, please try the following exercises. Sketch the graph of the following. Number 1, 2x minus 6 equals 0. This is a linear equation in one variable x. So when you draw the graph of this equation, it should be a vertical line. Number 2, you have 3y plus 12 equals 0. This is a linear equation in only one variable y. And when you sketch the graph of this linear equation in y, your graph, your line should be a horizontal line. In number 3, you also have another linear equation in y. So the graph of this linear equation in y is a horizontal line. But to construct that horizontal line, you have to solve first for y from this equation. And the first step is to remove the grouping symbols. In number 4, you have another linear equation in y. So the graph of this linear equation is another horizontal line, parallel with the x-axis and perpendicular with the y-axis. But to graph that line, horizontal line, you have to solve first for y from this equation. Now, for this equation, you cannot do cross multiplication. You cannot multiply y plus 3 by 4 and y minus 1 by 2 because the right-hand side consists of two terms. So to remove the denominators 2 and 4, multiply both sides of the equation by the lowest common denominator, or the lowest number that can be divided by 4 and 2. and that number is 4. 4 is the lowest number that can be divided by 4 and 2, and multiply both sides of the equation by 4, and then simplify to solve for y. If you have any questions about the lesson today, the graphs of linear equations in one variable, either linear in x or linear in y, you ask your question in the comments below. And in the next lesson, we will take up the graph of linear equation in two variables, x and y. Thank you for joining the class today, and do not forget to subscribe to my YouTube channel, Art Kalisan.